Describing chemical reactions. When we write an equation, reactants are written on the left of the arrow, products are on the right, and the arrow means yields, gives, or forms product. To write a word equation, we're going to write the names of the reactants to the left of the arrow. So for example, iron plus oxygen. The arrow, which means forms or yields. And then my product over here, iron 3 oxide. So reactants, iron and oxygen, product, iron 3 oxide. A chemical equation uses formulas instead of words. This is the same equation I wrote earlier in words. Now I've written it in formulas in a chemical equation. This is a skeletal equation. It shows the formulas. It doesn't show the relative amounts of reactants and products. And if you'll notice, they're not balanced. I have 1 iron to start. I have 2 irons to end with. So this is a skeletal equation. It just shows the formulas of reactants and products. You can add more information by indicating the physical state. In that same reaction, Fe plus O2 forms Fe2O3. Iron is a solid. Oxygen by itself is a gas. Fe2O3 is a solid. So that just indicates more information by putting the physical state. Sometimes you can add a catalyst to a reaction. A catalyst speeds up a reaction. So for example, H2O2 decomposes to water and oxygen. This reaction will happen. It will just take a while. A catalyst will speed up the reaction. So if I add a catalyst, I put it above the arrow like MnO2, that would indicate it is a catalyst. It's not a reactant, it's not a product. It's there to speed up the reaction. A balanced chemical equation describes the reaction in which each side has the same number of atoms and mass is conserved, because in every chemical reaction mass is conserved. We're going to add coefficients, which are small whole numbers placed in front in order to balance it. So the first step when we have a chemical equation is to write the skeletal equation. What are the formulas for the reactants and products? Then we're going to use coefficients to balance. Then we would check to make sure they're balanced on both sides. And then finally make sure all coefficients are in the lowest possible ratio. If you can reduce, reduce. So when you balance an equation, I always start on the left. Here's a few examples. I would start over here. Look at carbon. I've got 1 carbon on the reactant side. I've got 1 carbon on the product side. Carbon is balanced. Move to my next element. I just go from left to right. Oxygen. There are 2 oxygen here on the reactants. There are 2 oxygen on the products. So this equation is already balanced. The coefficients are 1. And you can write the 1s or you can just leave them blank. You don't have to include the coefficient of 1. Next example. 2 hydrogen over here. 2 hydrogen over here. H is balanced. 2 oxygen, 1 oxygen. Oxygen is not balanced. I need to add a coefficient out front. So I'm going to put a 2 here. The coefficient of 2 multiplies through the whole compound of water. So now I have 2 atoms of oxygen on the product side, but I also have 4 atoms of hydrogen, 2 times 2. So that means I need a coefficient of 2 in front of H2 to balance the hydrogen. So I've got 4 H's on the reactant side, 4 H's on the product side, 2 oxygen, reactant side, 2 oxygen on the product side. So the coefficients multiply through the entire compound. Next example. I always start on the left. Silver, 1. Over here I have 2. I need a coefficient of 2. That will balance the silver. Then I look at nitrogen. Well, there's actually 2 nitrogen because of the coefficient. Over here I have 1, so I need a coefficient of 2 to balance the nitrogen. Then look at oxygen. It's O3 multiplied by the coefficient of 2, so there's 6 oxygen on the reactant side. Over on the product side, 6 oxygen. It's okay. Next one's hydrogen. 2 H's. 2 H's over here in the product. H is okay. And then 1 sulfur, 1 sulfur. So everything is balanced now. 2, 1, 1, 2. And you can leave out the ones if you want to. Next example, notice there are lots of oxygen and hydrogen in this equation. I always leave the oxygen and hydrogen for the last thing to balance, especially if there's lots of oxygen and hydrogen. So in this example, I would balance the zinc. There's 1 here, there's 3 here. Balance the zinc. Put a 3. I'm going to skip the O's and H's. Balance the phosphorus. There's 1 P here. Over here, there's 2. Balance the P. Now you can come back and look at the O's and H's, and it doesn't matter which one you look at first. Let's look at O's. There are 6 O's in zinc hydroxide, and there are 8 O's now in H3PO4. So there's a total of 14 oxygen. On the product side, I have 8 in the ZN3PO4-2, and then I have 1 over here. Well, if I change the coefficient in front of zinc phosphate, that's going to change the zinc and the phosphorus. So I really don't want to change that coefficient. If I need to add more oxygen, I'm going to change the coefficient right here. So I've got 14 on the reactant side. I need 14 over here total. So I would need a 6 in front of the water. And that would give me 8 plus 6 oxygen, which would be 14 on both sides. Now if you go back and look at the H's, H's, I have 6 H's here plus 6 H's here. That's a total of 12. And on the product side, I have 12 H's. So the H's are balanced as well. So if you have a lot of O's and H's, leave those for the last thing to balance. And then number 5 here. Iron's okay. 3Cl. I need a coefficient there of 3 to balance the Cl. Sodium. Coefficient of 3 to balance the sodium. Oxygen. 3 oxygen here. 3 oxygen here. 3 hydrogen here. 3 hydrogen here. So that one is balanced. Balancing word equations. If you have word equations, you cannot balance those until you write the formulas. Hydrogen is H2 plus sulfur. Sulfur is just S. Forms hydrogen sulfide. Hydrogen with sulfur. Balance the charges. +1, -2. Hydrogen sulfide is H2S. And then you go back and add coefficients if you need to, but in this case, everything is balanced, so I don't need to. Iron 3 chloride, Fe, with Cl. Now iron is a +3 here. It says chloride's a -1, so FeCl3, plus calcium hydroxide. Calcium's a +2. Hydroxide is OH with a -1. Cross charges. Product side, iron 3 hydroxide Fe +3 with OH -1. So FeOH3 plus calcium chloride. Calcium's a +2, chlorine's a -1. Okay, so we have to write the formulas first, and then we can go back and add coefficients if we need to. Iron's okay. Chloride is not. We have 3 reactant side, 2 in the product side. We have to put a coefficient of 2 and 3 respectively in order to balance the chlorine. Now I changed the iron. I got to go back and put a coefficient of 2 to balance the iron. So iron's okay, chloride's okay. Calcium. 1 calcium here, 3 over here. Coefficient of 3 to balance the calcium. Oxygen. 3 times 2, so that's 6 oxygen here, 6 oxygen here. That's okay. Hydrogen, 6 hydrogen, 6 hydrogen. That's okay. So if you have a word equation, go back and write the formulas and then add the coefficients to balance.